Quadratic functions, section 9.2. Alright, our learning goals. Our objective for today is to graph quadratic functions of the form ax squared plus bx plus c. So the full-blown quadratic functions today. Alright, last time we kind of talked about, starting to talk about what the look of graphs would be, how you know what a minimum versus a maximum would be. And today we're going to just talk about how to graph those. We're going to find the axis of symmetry in the vertex. And here's just another example of a parabola, what the quadratic functions graphs look like. All right, so let's start off with a little bit of review. Oops. All right, so talked about this last time too, but we have multiple different parts of the quadratic function. The a value, I have two things that point to the a value. We have this one and this one. So the a value indicates if it opens up or down. If it's a positive value, it's going to open up upwards. Like the arrow is going to end up going upwards. It's going to be an actual U-looking shape. If it's a negative, it's going to go downwards. All right. That also will tell you if you have a maximum or minimum vertex point. But the a value also affects the parabola, and we talked about that last time too. When we have a Well, we're going to talk about that more today. But the smaller the absolute value of a, the wider the parabola. Meaning, if you have an a value of 1/2, that's a small number. It's going to be much wider than if you have an a value of 6. So think of it as this way: the bigger the number, the faster it's going to go up. So the narrower it will be. All right, then we have the x squared. That just tells you that it is a parabola. The b value will affect the position of the axis of symmetry. So the b value does change where the middle, I guess, of the parabola is going to be, that symmetry point, or that axis of symmetry. If there is a b value, your axis moves left or right. And then finally, the c value also affects the height of the vertex. So meaning, if you have a positive c value, it's going to move the vertex up. If it's a negative, it's going to move it down. Kind of like a y-intercept, almost. All right. So with that, we want to look at these three graphs. All right, all slightly different. We have y equals 2x squared plus 2x, and then there's no c value, so it would be plus 0. We have y equals 2x squared plus 4x, and we have y equals 2x squared plus 6x. What do you notice changes for each one? Well, hopefully you noticed that the x value of the vertex, the x value didn't change. It did slightly. The x value and the y value of the vertex changed. So here we go through the point x equals negative 1/2. When you have the 4 value here, we went through at what x equals negative 1. When we had a 6 as the b value, we went through x equals negative 3/2, or 1 1/2. Okay, so it ends up being a quarter of the value of the b value, and also a negative, interestingly enough. So notice how the b value moves the axis of symmetry. So the b value simply does affect where it goes left to right. So let's play around with that a little bit here too. If I have f of x, so y equals x squared minus 4. Let's add to the b value. Oops, gotta change that. All right, b value is 1. Let's go up to 5. That is moving the whole thing to the left more every time. All right, but then also the c value we're gonna play around with too. It moves it up or down more. If there is no c value, there we go. But if it's 0, 0, it's going to start at 0, 0. If there is no x or there's no b value or c value. All right, we kind of talked about this before. The bigger the a value, the narrower it becomes. It goes up faster. If you make it smaller, a smaller absolute value, I should say. Oh, looks like it's frozen here. So if you look at it, we're making it smaller, -1, and then the bigger the absolute value is, the narrower it becomes. So the closer to 0 it is, the wider it is. All right, so let's talk a little bit more specifically about how to graph quadratic functions. Here's something worth noting. The graph of y equals ax squared plus bx plus c, where a is not 0, so we're assuming you actually have an a value, has the line x equals minus b over 2a as the axis of symmetry. So that right there, this is probably the most important when you're graphing, most important formula. Minus b over 2a, minus b over 2a, minus b over 2a, minus b over 2a. That's how you find the axis of symmetry. Okay? So the middle of the parabola. The x-coordinate is the vertex. So we can use that x-coordinate then to find the y, and then you have the vertex as well. So here's going to be our procedure if you want to put it into words for graphing a quadratic function. Step 1, put the opposite of the coefficient of the x value over 2 times the coefficient of the y value. In other words, minus b over 2a. That number is the x value of the vertex, and it's also the equation for the axis of symmetry. Now, substitute this new x value into the original equation to get the y value for the vertex. And then we have the x and we have the y for our vertex. And graph the vertex. Now, select at least 2 values for x on one side of the vertex. So, like if the vertex x value is 0, we could do 1 and 2. That's to the right side. And we're going to find those y values. And then they'll give us the right half of it. Graph those points, and then we're also going to reflect those points over the axis of symmetry to make this the other half of the parabola. If you connect the dots, you'll create your parabola, or your U-shape, or upside-down U-shape, and you'll have the graph of the quadratic. So there's those steps. Feel free to pause it and write those down. We're going to actually put those into action right now. So here's how those steps broken down. For the equation y equals minus negative x squared plus 2. So if you want to write it out, the a value is -1. The b value is, there is no b value, which means the b value would be 0. And the c value is 2. All right, so rewrite in descending order. It's already in descending order, but we're going to put the 0x in there. All right, find the axis of symmetry. So that's minus b over 2a. Remember that, minus b over 2a minus b over 2a. So we plug that in for minus b over 2a. The b value is 0, so it's just 0 divided by 2. Well, the -2. I'm gonna move that. So when you plug them in, you get 0 or minus 0, but that's just 0, over 2 times -1, which is just 0. So the axis of symmetry is x equals 0. Now, to find the vertex specifically, where the vertex of this is, plug in that x value to find the y value that goes with it. So plug that in. That cancels out. We end up getting y equals 2. So our vertex is 0, 2. So that's where we're going to start our graph from. We then want to find 2 other points to one side of it. So if we plug in 1 and we plug in 2, so it's almost like, this is what I would say, we're making our T-chart. We got 0, 2. We're also going to find 1 and 2 for the x value. Plug in 1, you get the y value of 1. So our order pair would be 1, 1. Plug in 2, you get the y value of -2, and you get 2, -2. So we got 3 points. You graph those 3 points. So we've got 0, 2, 0 over 2 up, 1, 1, and 2, -2. Again, reflect those over across the axis of symmetry. This is the axis of symmetry. So that's worth writing in there with dashed lines so we know that. If you reflect it over, it's got to be the same distance on this side. So over 2. And now we have the other side of it, and it makes our upside down U shape. Remember, it's upside down because the a value is negative in this case. All right? So I'd like you to try it. We actually have a b value now. So find a graph or make a graph on your notes What is the graph of the function y equals negative x squared plus 4x minus 2? So why don't you pause it and try it, and I'll show my work, then you can unpause it and check it. All right, so I show my first work in blue to find the axis of symmetry, minus b over 2a. And I got x equals 2, so I graphed my line of symmetry at x equals 2. All right, and then I used that x value to find the vertex. I plugged in 2 for x and found the y to be 2 as well. So my vertex was 2, 2, so that's where I started it. And then I plugged in 2 other points on one side, so 3 and 4 for x's, and I got 3, 1, and then 4, negative 2. So I plotted those, and then plotted the reflection over the axis of symmetry for the other side of the parabola, and we have our upside down u of a parabola. And that's how you graph the function y equals negative x squared plus 4x minus 2. Okay, so remember the big one is minus b over 2a, and that pretty much gives you a good start on the rest of it. All right, I have one application problem then. Again, using the vertical motion model we talked about a little bit last time, but I want to just read through this example and kind of look at how it would work. Because a lot of times there is vertical motion, meaning things go up in the air and they come right back down. It's a real life thing. So that's why parabolas and quadratics are actually very usable when you think of physics and you think of how things go. So it says entertainment. During halftime of a basketball game, a slingshot launches t-shirts at the crowd. A t-shirt is launched with an initial upward velocity of 72 feet per second. The t-shirt is caught 35 feet above the ground. How long will it take the t-shirt to reach its maximum height? What about the minimum height? And what's the range of the function that models the height of the t-shirt over time? So the formula, the quadratic function that works for the vertical motion is h equals negative 16t squared plus 72t plus 5, where t is um, the time and h is the height. So it gives the t-shirt's height and t. All right, if we use t minus b over 2a, our x value for our t value, our time for our, this would be for our vertex, and for if we're graphing our axis of symmetry, will be 2.25 when we plug it in. And then the height at that time, if you plug that in, would be 86. Meaning, at its highest point, it's going to be 86 feet, and it'll take 2.25 seconds to get there. All right? And so then it says the range. We're going to find the range as it describes the height during the t-shirt starts at 5 feet. That's where we got that plus 5 at the end. And it peaks at 86 feet. That's the highest. So, and then it's caught at 35 feet. So that means the range goes as low as 5 and as high as 86. So here would be our inequality, our compound inequality, showing that the height of it is between 5 and 86 feet. Okay? All right, there's other ways to do it. You can use a graphing calculator, but we don't have those, so we're not going to use that right now. Our method worked just fine. So if you'd like to take a look at this one and try this one, I'll show the answer in just a second. But it says, suppose a t-shirt is launched with an initial upward velocity of 64 feet per second and is caught at 35 feet above the court. And we're assuming it's starting at the 5 feet again. Okay, but just remember, the last one was 72 feet per second, so that was this middle one. So we have to change the middle one. How long will it take the t-shirt to reach its maximum height, and how far above the court will that be? And then what's the range of the height? So how low does it go and how high does it go? So why don't you pause it, and I'll give you the answer in just a second. All right, so I found the vertex being t is 2, so that minus b over 2, I got 2 seconds that it takes to get to this highest point. And that highest point, then when you plug in 2 seconds for the t, is 69 feet. So that means that the range goes as low as 5 feet and as high as 69 feet. So you can demonstrate it in that type of a compound inequality. And that's how you work one of these vertical motion model examples. Very common real life example when it comes to parabolas. So I have one last thing for you to think about and try to figure out. It says describe and correct the error made by finding the axis of symmetry for the graph of minus x squared minus 6x plus 2. So try it, see if you can figure it out. If you can find an error, then go ahead and reflect on the goal that we're starting with at the beginning, which was to graph quadratic functions of the form y equals ax squared plus bx plus c. If you feel like you can do that now, that's awesome. If not, look back at the notes, look back at the video, ask for help. This is section 9.2 on graphing quadratic functions. Have a great rest of your day. Bye.